friends, welcome to my channel. I hope everyone is doing good. Today we are going to solve another tricky and interesting binary tree related coding question. It's on Leetcode 655 print binary tree. So this is a medium complexity coding question. Quite interesting problem to solve. So I would like to discuss this problem with you guys today. I created some examples so that you can clearly understand the logic as well as the solution how to solve this coding problem. If you are new to this channel, please subscribe to this channel now. It really helps and supports this channel. Here we create videos to help others in their coding and Java interviews. So let's start. Given the root of a binary tree, construct a zero-indexed m by n string matrix res that represents a formatted layout of the tree. The formatted layout matrix should be constructed using following rules. The height of the tree is height and the number of rows n should be equal to height plus 1. Okay. The number of columns n should be equal to 2 raised to height plus 1 minus 1. Place the root node in the middle of the top row, more formally at the location. So they have given us couple of rules here, and they are saying that any empty cells should contain empty string, right? And then continue this process until all nodes in the tree have been placed. Return the constructed matrix res. So I'll explain you with these examples. So number of nodes in the trees can be between 1 to 10, 2 raised to 10. The node values can be between minus 99 to plus 99 inclusive, and depth of the tree will be in the range of 1 to 10. Okay. So let's take a look at some examples, then it will be more clear for you, right? So let's take a look at this example. So this is the tree 1, 2, 3 and 4. So there are 4 nodes here. So if you so they have given us a tree in this form basically, right? In this form. So if you actually create a matrix, a 2D matrix here, then this is how the tree will look like, right? So 1 will be here in the middle here, then here 2, then here 4, and here is the 3 basically. So it appears like a tree shape here, right? Tree shape. So similarly, this example, if I construct a tree from this example, right? Whatever is this example, then this is how the tree will look like if you look at the tree structure basically, right? So 1, then 2, then 2 will have children 4, 4 will have children 8, 9, like this, right? And 2's children is 5, 5's children is 10 and 11. Then 1's child is 3, 3's is 6 and 7, and 6 children are 12. So basically, you know, because of these 2 digits and 1 digit difference, they look like this, but this is how the tree structure will look like. So this is what we want to create actually from the given tree, right? So I hope you are understanding this. This is another example for you guys, where you can clearly see here that this is the tree structure. So this is actual tree that is given to us, right? This is the tree that is given to us here. And if I take this tree and if I want to convert it into a 2D matrix, right? So this is how this will look like. So you can see here, one child is 2, 2's child are 4 and 5, right? Like this, and 4's child are 8 and 9, correct? And 5's child are 1 and 2, and once here right child is 3, 3's child is 6, 6 is 3, 4, and here is 7, 7 is 5 and 6. So in general, basically it will appear as this tree basically, as you are seeing in the form of matrix basically. So that is what we want to construct. Okay, this is what the problem statement says. So I hope you are getting the idea here. And if you go through their rules, then they will be saying that place the root in the middle of the top row. So you will see here sorry, that one is the root node here. So you are placing that in the middle of the top row, right? This is the middle of the top row here, right? And these empty strings are because it should look like a tree, right? So if there is nothing, we will put an empty thing there basically, because we want to create that tree shape basically, correct? So it should be something should be here, otherwise that tree shape will not form, correct? So we'll put empty strings there, right? So once child is 2 again, so and again you have to put empty strings here and on this side, right? Like this, so that the tree shape will be formed. Okay, so I hope you are getting the idea. So how can we solve this problem basically? So this is the tree that is given to us, right? So we are taking the same tree over here so that I can explain better. So what we can do to solve this problem is, now we want to first find out what is the how many rows are there basically. So we can find out the height basically. So this is number of rows, 1 2 3 and then 4. So these are 4 rows basically, right? 4 rows. So this is the height of the tree, correct? So height of the tree you can form, or you can find it using recursion. So we will simply implement a recursive function for that, which is very easy. I'll show you that. But once you find out the height, in this case how much is your height of the tree? 4 is the height of the tree. Then if I want to find out the total number of columns, so now we know the number of rows, right? Number of rows are 4 here, but how many columns are there? So if you calculate the columns, it will be like this: 1, then 2, then this is 3, then this is 4, this is 5, 6, 7, right? 7, 8. This is important that this is the 8th column, okay? Then 9, 10, 11, 12, 13, 14 and 15. So total how many columns we found? 15. So if I know the number of rows, right? If I know the number of rows, I can find out number of columns. How? 2 raised to 4 minus 1, right? 2 raised to 4 minus 1 will tell me how many total columns I can have there, right? 15. So this part you understood. This is the basic idea actually, and basic logic how you can solve the problem, okay? So number of rows, you know, this is 1 row, this is 2 row, this is 3 row, this is 4 row, right? So 4 rows are there and 15 columns are there. So this part you are clear with now. I showed you. Now I'll remove this so that we can reuse this space. So I know that 15 columns are there. It means that my middle column will be 15 by 2, which is going to be equal to 8, right? 8. So 15 by 2 in the sense 15 plus 1 by 2 basically, right? So it means that this will be my middle column actually, right? This is the 8th column basically if you calculate 8th column, right? So this is where I want to put that one, right? This one that I have first, right? I can put that one here, right? Here. After that, so now I put that one here, and in the beginning I will put the rest of the things as empty here and empty here. Everywhere will be empty in the beginning. Why empty? Because you see that we have to create empty strings all around that one, correct? So in the beginning we will put everything will be empty, okay, and we will just insert this, we will just update this value to 1 basically, okay? So this part is clear to you. Now one you form already. Now what you will do, you will recursively form the left part of that one. This is the left subtree of 1 and this is the right subtree of 1, correct? So you will recursively form it basically. How I will recursively form it? Now again this time to calculate where to put these two, I know this one is the 8th node. So these are actually maximum number is 7, correct? So from 1 to 7, right? 1 to 7 I have to put it, okay? 1 to 7 I have to put it. It means that I can just calculate this. So 1 plus 7, right? 1 plus 7 divided by 2 is going to give me 4. So it means that 4th column I should put this 2. It is 4th column, right? 4. Why 4? Because this is 1, this is 2, this is 3, this is 4, right? This is 4. So 4th column I want to put it here. How about the 3? 3, which column should go? So this one I put it 8th column. So what will be my range next time? 9 to 15, right? 9 to 15, correct? Okay, so 9 plus 15 is going to be 24, plus divided by 2 is going to be 12. So I should put that in the 12th column. How is the 12th column? This is 9, 10, 11 and 12. So in this 12th column I should put it. So this is the 12th column basically, correct? So I know the range. The important thing I want to tell you is this range I know from 9 to 15. That's how I can decide that where exactly that 3 should go, right? It should go in the 12th position there. So this part you understood, I hope. So now what did we do so far? So we put 2 and 3. So let me remove all this so that I can reuse this space. So we know that you placed this 4 here and this one is 12. So you know this, right? Okay. So now again recursively you have to build this part and this part basically, correct? As well as you will have to build this part and this part. So there are 4 parts you have to still build. So now again, if you know this 4, you know the starting point is 1 on that, on this left part, you know the starting point is 1 and your ending point is 3. You know that because this 4 is here. Okay, this 4 is here. It means that you can just divide it by 2 and it will give you 2. Correct, it will give you 2. It means that this 4 I am going to put at the location 2 because this is column 1, this is column 2 now, right? Similarly, so I will not go in the all the complete example, but I'll tell you this last one now. So 7, right? 7 means you know this, you placed it at 12 position. It means that the next position you have is 13 and how far you can go, 15, because you know already these things. Okay, so you have to just divide this sum by 2 and it will give you 12. 28 divided by 2 is 12, sorry 28 divided by 2 is 14. So it means that this is the 14th location you have to put it, right? Because this is 13, 14 and 15, so you will put it at 14th location, right? So it means that you can actually now create this kind of representation with the logic that I explained you in detail, right? So whenever you are placing this value, this 7, it is 14th column basically. As you see, this is a 14th column, this 6 should be which column, 15th column. So you will see that this is a 15th column basically, right? So if you calculate from here, it will be the last one, like that's why. Okay, so this way once you create it, it will look like this, which will give you a matrix representation for a tree, right? So I hope you understood this logic clearly. So let's do a quick recap before we can go to the Java code. So what do we have to do? First, we will implement that recursive function to find out the depth of the tree, right? So depth of the tree we can easily find out by using recursion. I'll show you that. So for example, what depth means is that for this complete tree, the depth is 4, right? The tree, this tree, the depth will be 3, like this. For this subtree, the depth will be 2, and so on, right? So this is how we will find out the depth. Once you find out the depth of the tree, you know number of rows, right? In this case 4. 2 raised to 4 minus 1 will give you the um, total number of columns that you will need actually. Okay, total number of columns you will need here in this matrix, right? So in this case they will be 15, right? And then you will start filling that columns based on the logic that I just explained you, right? Recursively. Okay, so let us go ahead, take a look at the Java code, then it will be more clear for you guys. So let this page come up. So okay, so this is our Java code. So first thing, I'll show you the find height function, which is the recursive function. So this is a recursive method basically. So it takes a root node, and if root is null, you will return 0. Otherwise, you will add 1 plus maximum between your left subtree height and right subtree height, right? So find height left root dot left comma find height root dot right. So you are recursively calling here this function and adding 1 to it. So this one will calculate the this is a standard way of recursion that you can use to find out the height of the tree. Okay, so this function is just a static function that we'll use from our main function. This is our main method. We will call it as a print tree. This method is going to return the result. So this is a list of strings, so which is array list, right? Okay, now this is our main method print tree. It takes a root of the tree, right, and it returns that list of strings. First we will calculate the rows, which by using the find height. I told you that in our case number of rows are 4 here. Okay, so we'll find out that here, and once you find out that, then you can calculate the columns. 2 raised to number of rows minus 1 will give you the number of columns that you want. Now you will, in this for loops, you are just filling that matrix, this matrix that I shown you. You are filling this complete matrix with empty strings like this. In the beginning everything will be empty, okay, in that matrix. That's what we are doing here. Okay, once we are done with that, now is the time to call our recursive method print tree. This is the important method here. Print tree, right? So what does this recursive method takes? It takes the root of that tree, it takes the root node, it takes row and left and right range, right? So in the beginning you are filling the 0th row, so you are passing 0 here, left is 0 in the beginning, and right is cols -1. In this case, how many columns are there? uh, so 16 columns total, 15 columns, right? So you will pass that as a right range. So you know the range basically, right? Once you know this range, print tree, you are actually first, this is the recursive method. So this is where we have a base case, it will terminate here. Okay, when your root is null, it means that you will return, you don't have to do anything in that case. Now here you will calculate the column where you want to place that value, left plus right divided by 2. In the beginning, you know that your left is 0, your right is um, left is 0, right is 15, or so if you are going with 0, then it will be 15, we are going with 1, so 1 and then 15 is your right basically. So 1 plus 15 divided by 2 will give you 8, and you go to 8th column and you place 1 here. So that is exactly what you are doing here, right? So you find out that column for where you want to place that node. Once you find out that exact column, you go to that row and you are updating that column to this value, right? So this is exactly result.get row dot set column with this value, right, that you want to set it. Once you are done, once you are done with this 8 value, now still you have to concentrate on this left subtree and right subtree. So it means that you are recursively calling that function now again. So this is the recursion. Print tree is calling print tree, it's a recursion. Here what you will pass, root dot left. So now root dot left, because a left subtree you want to print, right? Your row will be increased by 1 because you are going to go into the next row. This is the next row that you will place this 2, correct? You will place this 3 in the next row, correct? Okay, so row plus 1, left will not change. For the left subtree, left will not change, but right will change to column -1, correct? So what I mean to say is, for the left subtree, we are now concentrating on this left subtree. So what will change? The left will be still 0 here, but the right will be 7. If we are talking about 0, we are, in this case we are talking about 1. So 1 and 8 basically, right will be 8, right? Right will be 7, 1 and 7. Okay, so 1 and 7, so 1 plus 7 divided by 2 is going to give you 4. So you place this 2 at the 4th column basically, right, like this. When you are talking about this right subtree, what will change? Your left will change, your left will be 9 here, and your right will be 15, correct? So 9 plus 15 divided by 2 is going to give you 12, right? 12, and you will go to 12th location and place that 3 here at the 12th location. So that exactly what we are doing here. Okay, so row plus 1 is, you know, that next row, column plus 1. So left will change here, column plus 1, right will not change for the right subtree. Okay, so this way you will go in recursion in this tree, in this print tree method, and you will actually start filling that matrix, and your matrix will look like this basically, right? Like it will look like this once you print it, and that one should solve this problem basically, right? So let's give it a run and make sure this code is compiling and working correctly against the test cases. So as you can see, the code is working and compiling. So these are some examples I created for the testing purpose, and I also shown you that this is the example we saw. So we'll submit this code now. This is the same example that I shown you here, right? This is the same example you can see. So we are getting correct answer. So now we'll submit this code now to the Leetcode, make sure this code gets accepted. And as you can see on the left side, the code is successfully accepted by the Leetcode. It is 91.08% faster than other submissions, which is a very good solution and code to solve this coding problem on Leetcode 655 print binary tree. Medium complexity, interesting and tricky coding interview question that we have solved with the help of recursion and with the help of this row and column logic. So I hope you understood this solution completely and you like this example and this explanation. And if you like this example and explanation, and if this help you understand this problem in an easier and better way, then please give it a thumbs up to this video, give it a like to this video, subscribe to this channel. Your subscription is really important and valuable for us. It helps and supports this channel. It takes lots of efforts to come up with these examples and to explain these examples for you guys. So if you really want to appreciate these efforts, try to be generous and give it a like to the video. Subscribe to our channel, click on the bell notification icon button right away so you won't miss any upcoming interesting such videos. uh, we have more than 550 solved different varieties of coding problems just like this one, with examples and explanation with whiteboarding sessions for your clear and easier understanding. So don't forget to check out our important playlist for you. Here on this channel are graphs, matrices, binary search trees, binary trees, different solved problems using techniques such as binary search, dynamic programming, recursion, memoization, how to use and apply BFS and DFS on trees, graphs, matrices. Important data structure playlist for you. Here are stacks, queues, priority queues, min heap, max heap. So don't miss out on those important problems. Those are previously asked coding questions by big tech companies in their interviews. They will definitely help you in your interview preparation, as well as you can also learn more computer science and programming techniques along with Java programming by watching those videos. So go ahead, check out those playlists and tell us how you like those playlists. Share this video with your friends so they will also come to know about our channel. Watch these videos, they will also learn from these videos. Keep learning, keep coding, and thanks for watching these videos and have a great day ahead.